Welcome back, everybody. This is going to be part 1 of 2 in my lecture series on graphing quadratic equations. Let's get started. We should all already be familiar with what a quadratic equation is. It has the form ax squared plus bx plus c equal to 0. And the shape of its graph is called a parabola. Now, there's one quadratic equation that we already know how to quickly sketch the graph of, and that's f of x equals x squared, shown here below. But we have a vertex form for these quadratic equations that help us quickly sketch their graph. If we can write the quadratic equation in this form, f of x equals a times x minus h squared plus k, where a is non-zero, then we have a couple of quick tricks that let us sketch its graph. First of all, we know it has a vertex, and the vertex, by the way, is this point, sort of the top of the U, or the bottom of the U. It has a vertex at the point h comma k. If a is a positive number, it opens up. If it's negative, it opens down. The way I like to think about that is positive is the smiley face, negative, it's feeling down. So let's use these tricks to sketch the graph of this guy. Notice this is already written in vertex form for us. So first of all, we need to find the vertex. We know that the vertex is at h comma k. Notice in my formula, h has a minus sign, so I need to change the sign on h, but not on k. I've got a plus sign. So I get positive 3, comma, negative 4 for the vertex. Also notice that a is positive, so it opens up. Okay. This gives us a lot of information. If I draw a coordinate axis here, then I know where the vertex is. It is at 1, 2, 3, 1, 2, 3, 4 down here. But now I need to figure out a couple of other points on the graph. So one way to do that would be to plug some in. For example, what if I wanted to try f of 2? Well, I would get 2 times 2 minus 3 squared minus 4. Cleaning that up a bit, I get 2 times negative 1 squared minus 4, or negative 2. Similarly, if I try 1, then I get 2 times 1 minus 3 squared minus 4. Cleaning that up, I'll get 2 times minus 2 squared minus 4. That is going to be 4. So I know that the point 2, negative 2 is on the graph, and the point 1, 4 is on the graph. Now, here's where we're going to make our life a little bit easier. All of these parabolas have what is called an axis of symmetry, and it runs right through the vertex, a vertical line running through the vertex. So the axis of symmetry is the vertical line running through the vertex, so that's going to be at x equals 3. Now, this line gives us some valuable information because I can just reflect all of these points across the axis of symmetry like it's a mirror. Let me show you what I mean. Here, 2, negative 2 is on the graph. I can move 1 to get here, and then 1 to find another point at 4, negative 2. Same thing up here. I can move 1, 2 to get to the axis, and then I move 1, 2 to get to the point on the other side. 1, comma 4, becomes 5, 4. And now I have enough information to sketch the graph. And you'll have to forgive me, I am terrible at drawing pictures. That is horrible, and I can't believe I'm putting that on the internet. Now I've got one for you to try. See if you can sketch the graph of f of x equals negative 1/2 times x minus 2 squared plus 4. Go ahead and pause the video here and press play when you're ready. Here's the answer that I found. The vertex is at 2, 4, and we can get that from our vertex form. The x-coordinate is the opposite of this negative 2, and the y-coordinate is this positive 4. The axis of symmetry is the vertical line that runs through that x-coordinate. Notice that I'm graphing it with a dashed line because it's not actually part of the graph, it's just a tool that helps us draw the graph. And this guy, I know, opens down because I've got a negative a value. From there, I just needed to plot a couple extra points. I plotted 1, 7/2 and 0, 2, and then used the axis of symmetry to get the points on the other side. Now, here's a challenge problem for you. Can you sketch the graph of f of x equals 4 minus x minus 1 squared using its intercepts instead of the vertex form information? Go ahead and pause the video here. See if you can tackle it on your own. If you need a hint, let it play a little longer. Ready for the hint? The x-intercept happens when y is equal to 0. So we would set y, or f of x, equal to 0 and solve for x. Similarly, the y-intercept happens when x is 0. So we would set x equal to 0 and solve for y. See if you can take it from here. I found the x-intercepts to be at 3 and negative 1, and the y-intercepts to be at 3. Notice that I have two x-intercepts because this is a quadratic equation. I should have two solutions. Also, I can infer, based on the fact that my x-intercepts are 3 and negative 1, that right in the middle of that, at around x equals 1, I have my axis of symmetry. That also tells me my vertex is going to take place here. So that just gives me a little bit more information to sketch the graph. In this video, we saw how to sketch the graph of quadratic equations when they're written in vertex form. In the next video, we're going to take a look at how to graph them even when they're not written in vertex form. Catch y'all in the next one.